Now let's prove that every interior minima x star of a function f of x must be a stationary point of f of x. And this arises because of the mean value theorem from calculus, that for all epsilon, f of x star plus epsilon is f of x star plus epsilon times the slope f dashed, evaluated at a point psi, which is in between x star and x star plus epsilon, and that's true whether epsilon is positive or negative. Okay, so how do we do this? Let's rearrange the mean value theorem slightly. So f of x star plus epsilon minus f of x star must be this product of epsilon f dash of xi for whatever xi is appropriate. Then we bring in the fact that x star is a minimum. Right, so what do we know for a minimum? We know that all the neighbouring points, namely f of x star plus epsilon, must be bigger than or equal to f of x star, provided epsilon is small enough. If epsilon is big, then all bets are off. But small enough epsilon, this has to be true for all small epsilon. Now, what does this mean? It means the difference between f of x star plus epsilon and f of x has to be bigger than or equal to 0. So this tells us that this product, epsilon f dashed of xi, is bigger than or equal to 0. So two things then follow. In the case when epsilon is positive, the product is positive, that says that f dashed of xi is bigger than or equal to 0. Conversely, if epsilon is negative, the negative number times f dashed of xi has to be bigger than or equal to 0, so that says f dashed has to be less than or equal to 0. Now, let epsilon go to 0. Going to 0 is small enough so that all this holds. And we'll go to 0 from positive and negative epsilon. Now, one of the first things that we can comment about epsilon going to 0 is what happens to xi. Xi is squeezed between x star and x star plus epsilon. So as epsilon goes to 0, we know that whatever xi is, it tends to x star in that limit. So then these two results tell us that as epsilon tends to 0, f dashed of x star is bigger than or equal to 0. And this second result tells us that f dashed of x star has to be less than or equal to 0, provided the derivative is continuous. We are dealing with smooth functions here, and so the derivative is continuous. Right, and the only way that these two statements can be true is if f dashed of x star is precisely 0. Hence, the minimum has to be a stationary point of f.